All right, welcome to part 2 of chapter 10, section 4 on proofs with perpendicular lines. This is the one example from our notes where we were asked to find the distance from point A to line BD. Sorry for the sloppiness of my diagram. It's a lot cleaner on the notes and in the solutions. But this is a very, very important example from this chapter, and we're going to see something very similar in section 5. And we're basically going to break this down into a 3-step process. Okay, and if you've already looked at the solutions and the resources to this section, you've already seen this process worked out. I'm just going to work through it in real time. This is a lengthy process. This tends to be one of the more frustrating type of problems for my students in this class. So please pay close attention and rewind, pause as you need. These problems tend to take somewhere between 10 and 15 minutes to solve. I'm going to try and do this a little bit faster so you can kind of see it more, the solution in real time. So as explained in the previous video, finding the distance between a point and a line is not as simple as just connecting that point to one of the other 2 points that you're given. Our job here is to find the perpendicular distance from the point that connects it to this line. Okay, so we're going to break this down to a 3-step process. Step 1, we're going to find the equation of the perpendicular line that connects the point to this object being line BD. And it's very tempting for students to just say like, oh, well, A is closer to D than it is to B. That must be the distance. Okay, that's not true. That would be the distance from A to D, something we've done in a previous chapter using the distance formula. We're going to use the distance formula again, but in order to do it accurately here, I need to find the shortest possible distance, and the way I do that is by finding a perpendicular line. So I'm going to kind of use the similar structure as I did in the solution set in your resources, so feel free to check on Google Classroom for that as well if you want to follow along with that. But our first step here is to find the equation of the perpendicular line. So this is the operative right here, perpendicular. And hopefully you remember this fact. If I have 2 lines that are parallel, the slopes have to be equal. And the reason I'm going to focus back on slopes is because I'm dealing with a coordinate grid. So I can find slope. And this line BD, I can actually find the slope of that line. Again, forgive the sloppiness here, but essentially, if I want to find the slope of line BD, I would just do rise over run. It doesn't matter which direction I go. I usually go from left to right, like reading a book. So I can see here that from B to D, I went rise or up 3, and then run or over 3 to the right. Up is positive, right is positive, so I have up 3, run 3. My slope of BD, this is a valuable thing to have, my slope for BD is 3 over 3, which reduces to 1. Convenient enough. So one of the first things that you're going to want to do here is you're going to be given a line, find the slope of that line. That's going to be useful. That's not going to be the same slope I use for my new line. The reason I brought up that before is if I was finding something parallel, I would just copy and paste that number. But the operative here is that I'm dealing something perpendicular. Now, if you need to write this in your margins of your notes, please do so. But for perpendicular, that means I'm going to be using the negative reciprocal or the flip the sign, flip the fraction version of this. Okay, so I found the slope of this line just by doing the rise over run. I'll be giving points, and you'll see this on big A's as well. I find the slope, and what I'm going to do is I'm going to be changing that slope. Okay, so I'm going to be changing this 1 into its perpendicular version. So I'm going to flip the sign, flip the fraction. This is a positive 1. It's become a negative, flip the sign, and then flip the fraction. If you need to write this in fraction form, it doesn't really matter, but it can be helpful. This is a 1. Technically, it's 1 over 1. So if I flip the fraction, 1 over 1 becomes 1 over 1 again. Right? Now, if I had like a 2 or something that's 2 over 1, then it becomes 1 over 2. Okay, be careful with the flip the fraction part. This one's convenient enough because 1 in reciprocal form, that's the fancy math term, but if I were to flip the fraction here, it actually becomes 1 again. So flip the sign, positive to negative. If I started with the negative, it becomes positive. and then flip the fraction. 1 over 1 becomes 1 over 1 again. So this is what I would call my perpendicular slope. That's the one I'm going to use. Okay. Now, if I need the equation of the line, I not only need the slope, the perpendicular slope specifically, but I need the y-intercept of that line. Now, just to relate back to this graph, when I say this slope, that's the slope that's going to connect that point A to this line BD. I'm going to connect it with the slope of -1. Okay, but here's how you can do it mathematically. I'm actually going to use point-slope form. Point-slope form. So many of you will recognize this formula. Y minus y1 equals m times x minus x1. That's point-slope form. I just found the slope of my new line, so m is going to be -1. But what point am I going to use? What point am I going to be connecting to this line BD? It's point A. And so since A is the point -3, +3, and in some cases you'll just have to read the graph to find that coordinate point. In some cases you'll actually be given that exact coordinate point. Whatever it might be, I have a point, and I have the perpendicular slope that's going to connect it to line BD. So using point slope form, now I'm going to be plugging in these values, the slope and my point, into this to find my equation of the perpendicular line. So using this, I get y minus y1 is my y coordinate from this point, so it's the +3 here. Be careful of sign. M, that's what we just found with my perpendicular slope, is -1. And then times x minus x1. Well, x1 is my x coordinate point from this point, namely it's the -3. So if it helps you, make sure that you write the negative over again. And we'll simplify this. Whenever I subtract a negative, that's the same thing as addition. And so just to simplify this, I'm going to get y minus 3 equals -1 times x plus 3. All right, and so what I'm going to do now is if I want this in y equals mx plus b form, I'm going to distribute this -1, and then I need to move this -3. And the way I would move that is by addition. All right, so let's do this in 1. Distributing the -1, I get -x, and then -1 times +3 gives me -3. Now I'm going to add the 3 to the other side. 3 plus a -3, it's going to cancel and go to 0. That will not always happen. Just make sure you follow your general inverse operation rules. Again, it will not always be 0. It happens to be this. In this case, this is going to become y equals -x. If you want to put the +0 on the back end of that, you can. It doesn't really matter. But this will be the equation of my perpendicular line. Now, why does that matter? If I were to actually graph this line, here's what would end up happening. If I were to graph -x plus 0, the +0 tells me it starts at a y-intercept of 0. The -1x that's technically there tells me the slope, so I would go up 1, back 1, up 1, back 1, up 1, back 1, and you'll find that's going to intersect with A to BD, and here's what's going to end up happening. I already kind of graphed this down here. We created a perpendicular line that connected A to BD. Why did this matter? Now I can measure distance between the points that are connected here. Okay, so that's the purpose of step 1. It's a critical step here. So step 1, find the equation of the perpendicular line. Very important step. All right, we're going to move on to step 2 now. So ultimately, if I need to find a distance, I need a distance formula, right? I need to find the distance between some point and another point. The trick now is that all at this point I have a perpendicular line crossing another line. I need to find out where they intersect. Now, here's the convenient thing with this example, and with pretty much the examples you're going to come across in section 4. It'll be a nice clean point. If on your graph paper you had done this, it's a little more difficult to see it here on my whiteboard, but if you did this on graph paper, you would find this very conveniently crosses at a nice clean coordinate point, namely 1, -1. If you're able to eyeball it like that, use it. It saves you a little bit of work. But technically, mathematically, step 2 here is to find my intersection. Basically, before I can use distance formula, I need to have 2 coordinate points to compare. I have one. We started with this one, point A. But I need to find where it intersects my line. It will not always be this convenient. In this section, it probably will be. I'm going to prepare you for section 5, though. In section 5, you're going to get some less friendly numbers. But here's how we can do this. We actually did stuff similar to this in chapter 5 back in first semester. We now have a system of equations. Okay. Basically, I have a starting the equation we just found. I have y equals negative x. That's the equation of my perpendicular red line right here. I also have line BD. Line BD I can write as an equation as well. I just need a slope and a y-intercept. Well, the slope we already found. The y-intercept is just where it crosses the y-axis right here, which is at -2. So basically I have the equation of line BD. I'll write it in a different color just so we can kind of distinguish between the two. But my second equation, this is technically what, in some cases on some of these problems, they'll actually give you the equation of the line. Keep that. This will come in handy for step 2, what we're doing right now. Otherwise, you can kind of pull the equation out of what you're given as a graph. Well, the slope of line BD we already found was 1. So you could write 1x or just x. And then plus b, the y-intercept, is here at -2. Again, we're talking about line BD right here. Crosses the y-axis at -2. So my b is this. So this is the equation of the line I was given, line BD. This is the equation of the perpendicular line we just found. We now have a system of equations. And just to remind you from chapter 5, a system of equations is just means more than one line. So if I want to find out where they intersect, I can actually set them equal to each other because they both equal y. So I can get -x equals x minus 2. That's important because now I have one equation, one variable. I can get that variable by itself. Tempting to say that these two cancel, they actually don't. If I want to combine this x with this one and I want to cross this bridge, I need to subtract it because it's positive. So if I subtract x over here, I'm actually going to get -2x equals -2. Divide by the -2, I get x equals 1. What I've just found is I found the x coordinate point where they intersect. There's that +1. Okay, again, on a graph paper, maybe you get nice clean intersections, so you don't need to go through this process, but it can come in handy. So now, how do I find my y element? By simply plugging in x into either of these equations. It does not matter which. So if I plug it back into this one, y equals a negative version of x. Well, a negative version of 1 is -1. This is my coordinate point. There's the -1. If I plugged 1 into this one, 1 minus 2, also -1. Doesn't matter which one I go back into, but now I have a coordinate point. This is my intersection point. And yes, it's nice and friendly right now, but if you had gotten something that was a weird decimal or a fraction, it's useful to have this because I need an accurate distance. So this process is about finding the intersection. Now I have a second coordinate point to compare to my first for step 3. And this one will be super quick. This one goes back to, again, a previous chapter where we used distance formula. So step 3, distance formula. And I'm going to do this pretty quick. I'll go ahead and write down our distance formula here on the side. It's this massive square root, x1 minus x2 quantity squared plus y1 minus y2 quantity squared. There's our distance formula. I'm going to ask you to refer back to our solutions in your other resources, just because I'm limited on time here due to my document cam. I have a 15-minute time limit. But this is the formula we end up using. Where did the x1 and x2, y1, y2 come from? Well, I'm going to be comparing A, which was -3, 3, something you may start with, and our intersection point, which was 1, -1. So there's x1, y1, x2, y2.